Good morning, Altan. Good to see you here. Uh, we will just
Good
begin.
morning, Rabia.
We'll wait others, trickle in. Good afternoon, everybody in Pakistan, and a very good morning to Altan in the US. It is a pleasure for me to host Dr. Altan Allawala today for a CSSPR webinar on artificial intelligence and international security. Altan is someone whose work I've been following with much interest and whose genius I've witnessed firsthand. Altan holds a PhD in theoretical physics from Brown University. His thesis, which was in the area of statistical physics, used machine learning to predict the behavior of nonlinear chaotic systems. He has also taught a number of courses such as quantum physics, special relativity, and statistical physics. Altan is a founding member of the Machine Learning Center of Excellence at J.P.Morgan. Within the firm, he develops machine learning packages to solve industry problems in anomaly detection, such as fraud. He has also written white papers on various machine learning topics relevant to the industry. Additionally, Altan provides machine learning training to the wider community and is currently creating an online machine learning course which will be open access and free to anyone. So I'm looking forward to that so that our students and faculty can join your course once you launch it online. So over to you, Altan. You can introduce your topic to the audience, and then you can start the screen sharing.
Thanks, Rabia, for this very warm introduction. It feels, really good to be able to give an AI talk in the country where I was born and raised. So thank you for this invitation. And I also feel like we've somewhat come full circle now, because I still remember the day when you came to my university, Brown, to give a talk on international security. And now here I am virtually giving a talk at your university, the University of Lahore. So just for the benefit of everybody here, when Rabia asked me to give this talk, I asked her who the audience would be. And she said a large chunk would be the School of Integrated Social Sciences. So in the spirit of integrated sciences, I've put together a fairly cross-disciplinary talk, which will cover several different fields. I'm going to, in fact, be going beyond cybersecurity and talking more broadly about general international security. So I've changed the title of the talk accordingly. Let me switch screens and we can begin. All right. So AI and international security. Before we go into the international security part, I want to spend some time focusing on the AI part. What exactly is AI? Is it a buzzword? How is it related to other popular terms that you might have heard, like machine learning? And then finally, how does it impact international security? You can see that there are some fairly serious people who think that it will impact not just international security, but the entire species security. And so we're going to try and understand why some people have this viewpoint. And we'll start off by looking at what exactly AI is. So AI is just the field of making intelligent machines. But when we talk about intelligence, there's a problem. And the problem is that the word is ill-defined. So, for example, for a long time, modern society had a very narrow view of intelligence. It was considered the ability for critical thinking and logical reasoning. And, in fact, one of the major criticisms of the educational system all over the world is that it's been putting too much emphasis on this one type of intelligence. And then over time, more and more forms of intelligence were added. For example, in 1983, this theory of multiple intelligences was proposed. And so things like musical, kinesthetic, interpersonal intelligence were also kind of added under this umbrella of intelligence. And this list continues to grow. But even though it's growing, these notions of intelligence are still created by humans and for humans. And so our conception of intelligence is by construction human-centered. Now, why is this a problem? Well, here's an example why it's a problem. The human brain contains these specialized neurons, which are thought to be responsible for things like social organization, empathy, emotional intelligence, things like that. The remarkable thing is that the orca brain, and you can see some pictures of orcas here, have brains with 3 times the number of these cells, even after correcting for their larger brain size. And what's even more incredible is that researchers did an MRI of an orca brain, and they found, unsurprisingly, many of its brain structures were generally quite similar to humans. But interestingly, they found one region of the brain that was far more developed than it is in humans. And in humans, this part of the brain is related to speech. So could orcas have a language that's more sophisticated than humans? Maybe. But if not, then what kind of intelligence does this part of the brain do? To this day, we still don't understand it, nor have we even come up with a word for it, because our conception of intelligence is human-centered, and hence our way of identifying it is also human-centered. So the point is, it's been hard enough to come up with a definition of intelligence that encapsulates all the different flavors of human intelligence, like all of these. And we've barely scratched the surface of coming up with a definition which also encapsulates non-human, yet still mammalian intelligence. And so the idea of coming up with a definition of intelligence that encapsulates not just human and general animal, but also inorganic artificial intelligence is way beyond our current frameworks. And, by the way, that's not to say that intelligence is not a useful word. In a conversation, it can convey a lot of valuable information. But in a field like computer science, which is, sort of like a precision sport, you need words that can capture concepts precisely. And intelligence is just too loose of a term, which makes it very difficult to make any meaningful headway. So instead, in the AI community, we use a different term, learning. Learning is a term we actually can understand in a precise way. And to understand what learning means, we need to first understand that there's this dichotomy that exists between two different concepts, memorization and generalization. Memorization is where you just commit something to memory, obviously, without analyzing it or understanding it. It's completely brainless work. So for example, when a camera takes a picture and stores it, it's effectively memorized the image. And so if you have photographic memory, you could try to use this technique to pass an exam, but you wouldn't feel very confident going into this exam, because if a question appears that you have not seen before, you won't be able to give the correct answer. So instead, if you want to feel confident going into that exam, rather than memorizing the material, you need to extract the general principles from the material so that you can then apply them to unseen situations. And this is called generalization. And so the process of going from memorization to generalization is what we call learning. Humans do it, animals do it, and machines are now doing it too. And so machine learning is now a very precise term. It's the field of using and making machines to learn principles from some sort of a training data set and applying these principles to new situations. And I'm just going to pause here because this is arguably the most important slide in this entire talk. Okay, so the goal of machine learning is to be on this side of the spectrum, where it's learned general principles from the data, which it can then apply to new data that it has not been exposed to before. So, taking a step back, AI, artificial intelligence, is a fairly hand-wavy term. It's just the field of making intelligent machines. Within AI, you have machine learning, and machine learning is the field of making machines that learn through experience using this whole framework of memorization versus generalization. So they improve their generalization abilities as they get exposed to more and more data. And by the way, the terms AI and ML are often used interchangeably. Um, and also similarly, the terms machine and computer algorithms are also often used interchangeably. So ML could also be the field of making computer algorithms that learn through experience. Okay, and then finally, within the field of machine learning, you have a further subset called deep learning. And deep learning is what's been generating the vast majority of the hype over the last few years. And I'm going to say that deep learning is machine learning on steroids. So why do I say that? Well, machine learning needs three ingredients. It needs the data, it needs the algorithm, and it needs the computational power to train the algorithm on the data and thereby extract the underlying signal in the data. In other words, to learn the underlying principle. And that's sort of summarized by this figure over here. So as your input, you're feeding it in data, and it's being fed into this algorithm here, which is processing that data and outputting the learned signals or the learned principles. And this algorithm here is being powered by your computational power. So you've got these three ingredients, and out comes your learned signal. And so that's machine learning. With deep learning, you have the exact same three ingredients, but everything is bigger. The size of your data sets are massive. It can be more data than a human being could be exposed to in 100 years. The algorithms are highly sophisticated. Many of them were only recently discovered. And finally, the computational requirements are also massive. So for example, at my work, we don't use CPUs to train the algorithms. We use these racks of GPUs, and each one of these GPUs has a computational power of 100 CPUs. So that's deep learning. You scale up everything, the data, the algorithms, and the computational requirements. Now, why has this only recently gained traction? Well, it's all about the data. Data is now easier to collect, store, and process. It's easier to collect because most of our world is now online. And so we're constantly generating data in everything we do. It's easier to store because storage has become a lot cheaper. And it's easier to process because of Moore's law. So Moore's law has ensured that the number of transistors that we can pack into a square inch of an integrated circuit has grown exponentially over the last half century. And so with more transistors, we have more compute power, and hence we can actually train these complicated algorithms on the big data. So these are the three reasons that we've really seen a lot of hype and interest being generated in the deep learning field in the last few years. And data here really is the key. So this chart shows the performance of an algorithm as a function of the amount of data that it's trained on. And so for your old school learning algorithms, like linear regression, the performance would keep improving as you increase the amount of data until eventually it would hit a kind of a plateau. And so the more data you gave it, you wouldn't really get much more bang for your buck. But now for deep learning algorithms, as you increase the amount of data that it can be exposed to, its performance keeps improving. It doesn't suffer from the same kind of a data saturation issue that these older learning techniques suffer from. So this chart really sums things up. So let me just summarize this again. For most of our history, we've been here in the small data regime. And in the small data regime, these older learning algorithms do a perfectly good job. In fact, they're even slightly preferable to deep learning algorithms because they're easier and cheaper to train. But now that we're in this regime here, this big data regime, deep learning algorithms are really outshining and opening up new doors for us. So let's think about the implications of this for a moment. 200 years ago, we had the Industrial Revolution. Okay, so factories were made, output increased dramatically, and the cost of products dropped. But what was the crux of this whole revolution? Well, the crux was that muscles were replaced by machines. You didn't need to be paying humans to do what a machine could do much more effectively. And so today we're going through this AI revolution, and this time it's brains that are being replaced by machines. And it's happening for the same reason as last time, which is that you don't need a human to do what a machine can do more effectively. And so because you have this automation occurring, some jobs are going to be lost and some jobs are going to be created. When the Industrial Revolution was happening, those countries that were the first to embrace it really came out ahead. So the question is, how can the country reap the rewards of this ensuing AI revolution? Okay, that's the question. Well, machine learning needs three things, as we saw. It needs the compute power. That's easy. Just go out and buy the right equipment. It needs the algorithm, which means it needs experts who know how to apply the algorithm. That's a little bit harder than purchasing equipment, but still not too difficult. It just means investing in machine learning training. But the biggest obstacle the country is facing is that we don't have the data. And it goes back to this chart here. We can only reap the rewards from deep learning and other sophisticated ML techniques if we have large data sets. So how do we get them? Well, let's look at companies with some of the largest data sets on the planet. Amazon, Google, Facebook. How did they get their massive data sets? Well, these are fully online platforms. And so their customers generate the data for them, and all they have to do is collect the data. So digitization here is the key. In order to collect high quality data in large quantity, the platform needs to go digital. Okay. Now let's dive into the applications of AI. This slide here shows a small subset of AI applications. And the reason I say the form of ads are shown to them to sway their opinion on something. And this often happens when there's an election approaching, by the way. So this is actually exactly what happened in the Cambridge Analytica scandal, So these guys were a British consulting firm, a British political consulting firm, and they were hired by the Trump presidential campaign in 2016. And apparently they were successful in swaying the elections. So how did they do it? Well, let's take a look. The first thing they did was they paid a few 100,000 people to do online personality surveys. And they then managed to get access to their Facebook data, meaning their clicks and their interests on Facebook. And they then trained a machine learning model to predict the personalities from the Facebook data. In other words, this machine learning model acted as a bridge between the Facebook data they collected and the personality information they collected. So you feed the Facebook data into the ML model, and it will output to you the personality. And so once they now had this machine learning model, they used it to predict the personalities of around 50 million Americans on Facebook. And so now, knowing their personalities, they could show them the sort of political advertisements that each specific personality was most susceptible to being swayed by. Okay, so for example, if say you were predicted to have a paranoid personality, then you would be fed fear-based advertisements. Alternatively, if you were predicted to be conservative, then the messages and ads you were shown were based around things like tradition and community. Okay, so that's how they managed to do this. Now, how much did this cost them? Well, it was actually pretty cheap. Each of these 300,000 people who they paid to do the survey, they were paid a few dollars, around $3 to $4 to complete the survey. So that's around $1 million plus the Facebook advertisement campaign. And in return, they effectively influenced the election of a US president who over the next few years would be making decisions that would have an impact worth trillions. And so if you just do a very crude back of the envelope calculation, the kind of, you're investing millions, you're getting back trillions, and that's a return on investment that you rarely see in today's world. And so this is the reason why we're going to be seeing more kinds of, these instances happening in the future. Before they were forced to close operations, they had actually influenced hundreds of elections globally already. And the only reason they were eventually forced to close down business is because the way that they obtained their Facebook data was illegal. So had it not been for this piece here, these guys might still be operating. Everything else here is legal. Predicting people's personalities, showing customized ads, swaying people's beliefs, that isn't illegal. And there are actually many other companies similar to this one that have come up. So it's important to just know that AI can be used for political campaigns, and it can also be used for misinformation campaigns. Okay, so that's social engineering. Now I want to switch gears a bit and talk about a completely different form of machine learning called reinforcement learning, or RL. The interesting thing about RL is that it's a form of machine learning that doesn't need data to train the algorithm. Instead, you have an agent that learns by interacting with its world around it. So it interacts with its environment. And this chart here kind of sums up what the framework for RL is. So at every point in time, this agent here, which is the brain, receives some kind of observation of the state of its world. And then based on that observation, it performs some kind of an action. and it then performs the action, and based on the action, it receives some kind of a reward for making that action. And obviously, now that it's done the action, the world has slightly changed, and so it receives in the next moment of time a new state observation of its world. And this process just keeps iterating onwards, on and on and on. And so one of the cool things about RL is that because you don't need large data sets, you can train these things by just letting them run loose in an environment. And they're just going to learn like a small child would learn. They're going to learn by trial and error. Okay, if I try this, what happens? If I try that, what happens? And because these things are computers, their rate of evolution is far quicker than anything you would see in the natural world, in organic systems. And so for this reason, you can get RL with these superhuman abilities. One more thing to mention about RL is that we can specify any reward function that we want. And then this RL agent is just going to figure out all by itself what the best actions are that will maximize the reward function. So you can kind of think of it like an optimization problem. You're optimizing the actions. You're trying to find the actions that will optimize a reward function. And so this is a general framework of RL, and it's got a lot of applications in situations where you want an autonomous agent. So, these days in the news, the famous ones you'll hear about are self-driving cars, or maybe AlphaGo, which beat, the world champion at Go. But in terms of an example that relates to international security, it would be unmanned aerial vehicles, or UAVs. And so how would you train an agent to autonomously fly a UAV? Well, the first thing you need to do is you need to prescribe a reward function. And there are all kinds of choices depending upon your use case. It could be something like the number of seconds your UAV stays in the air before crashing. Okay. Now, one important point, which I want to just note, is that you don't have to train these agents while they're actually physically flying in the air. That would be extremely slow and expensive. You can instead train them on a computer because we know the laws of physics, and so we know what action from the agent would produce what kind of observation in the following instant, and hence also what reward it would produce. And so if you train this agent on, say, a GPU for, I don't know, only an hour, the agent could effectively gain hundreds of years worth of flying experience. Hundreds of years worth of flying experience, something no human could ever hope to accomplish in their lifespan. And so what this does is it leads to agents with truly superhuman abilities. So what I want to do now is I want to play a recording of an autonomous helicopter that was produced by a lab at Stanford University. This video is going to be a bit choppy, by the way, because Zoom is doing this downsampling on videos, so my apologies, but I think you're going to get the gist. By the way, helicopters are much harder to fly than quadcopters because they only have 2 blades instead of 4 blades. And so they don't have as much stability. But even so, this RL agent has learned how to fly the helicopter in a way that is completely unintuitive for a human being. So in the lower right, you can see the names of the different flying modes that it's learned. It can fly upside down. It can fly in reverse. It can do all kinds of evasive maneuvers. Okay, it's flying in reverse right now. Now it's upside down. And it's this intuitive aspect of RL agents which I find most fascinating. Um, Intuitive for it, unintuitive for us. And the reason I find it fascinating is because unlike humans who have, a lot of rigidity in the way of their thinking, RL agents are trained from scratch. Okay, they're trained from a clean slate, and so they can find some very creative solutions to problems. Um, and similarly, they can also find very creative ways of achieving an outcome. And so they can end up finding ways of doing things that would be completely unthought of and unheard of by a human being. So that's one of the very interesting things about RL. So on that note, I want to share a joke, a joke here. Some of you might have probably heard of this thing called the Turing test. It's also called the imitation game. It's this test that was invented by this mathematician called Alan Turing. And it's basically a way to test whether a human has achieved intelligent behavior equivalent or on par to a human being. And so the joke here is that we shouldn't be afraid of a computer that finally passes the Turing test. In fact, we should celebrate it because that's a great achievement. But if a computer has instead achieved such a high degree of intelligence that it not only passes the test, but chooses to intentionally fail the test, that's when we know we're in trouble. Okay, so I'm going to end here. Obviously, the subject is huge. And what I showed here is just a simple unarmed helicopter, but the security implications of RL are pretty clear when you think about UAVs. But I'll go ahead now and I'll open it up for Q&A. I also want to mention that, if you want to contact me, you can get in touch with me on my website. And for anyone who's interested, I've created, as Rabia mentioned, an online free machine learning course. It consists of around 20 talks that go into all the technical details of machine learning that I didn't have the time to go through over here. And so that's going to be available here on the same site. Thank you.
That's fascinating, Altan. Can you stop the screen sharing? Yeah, okay, thank you. This was wonderful. I really enjoyed it, and I'm sure all of us, who are part of the session today, have benefited from this. So I will pose. We have questions for you, but I will start by posing a question myself, if that's you take that, and then we move to the other questions. So this helicopter bit was really fascinating. And the question that came to my mind is, we as humans keep talking about our sixth sense, our intuitive, capabilities. So can intuition be learned? Yeah, can humans acquire it rather than it just coming to us from some supernatural thing? So can intuition be learned? That's my first question. And the second is that almost everybody's familiar with Stephen Hawking's, and he was of this view that humans are going to self-destruct themselves with the way this evolution of AI is happening. So are we making ourselves obsolete if we know we are going to end up where we are going to end up with these machines being superior to us in every aspect? Why are we not stopping? What's the high here? So over to you for that.
I think you really hit the nail on the head here, Rabia. So let me give you an example which relates to both your questions. I mentioned briefly about the AlphaGo um, algorithm that a team had made. And AlphaGo, just to provide some context, Go is this ancient Chinese game. It's been played for thousands of years. It's older than chess even. And the Chinese culture has been has been specializing in solving Go and doing a great job at playing Go, to the point that they've now, the vocabulary has hundreds of words related to specific Go strategies and formations on the board. And for the longest time, AI researchers thought that Go is going to be an impossible problem for a machine to solve. The reason being that the number of configurations you can have on a Go board, it's I think a 64 by 64 board. The number of configurations you can have is more than the number of atoms in the known universe. And so the thinking was there is no way we'll ever be able to train an RL agent to beat a human at Go, because humans have things like intuition, and it's hard to program that. And yet, lo and behold, a few years ago, this team at Google made the AlphaGo algorithm, and the way that this algorithm was functioning was completely unintuitive to a human being. And that's why I said unintuitive to us, intuitive to it. Because during, I think, the third match, there were 5 matches played between the world champion at Go and this algorithm. And during, I think, the third match, the whole of China had uh, tuned in to the matches, and you had commentary going on, and you had people huddled around their screens, families huddled around their screens, seeing this algorithm beating this famous Chinese world champion. And during the third match, the algorithm made a move, and everybody threw their hands up into the air and they said, aha, it's made the wrong move. There's no way that that move can turn out to be the correct move. And yet it turned out that that move actually caused it to beat the champion by the end of the match. It planned so far ahead that humans, obviously, they weren't able to plan as far ahead. And so to a human, it seemed unintuitive and actually completely incorrect. But in the end, the proof is in the pudding. So that's about, can intuition be learned? I think it can absolutely be learned. And I think, humans themselves do learn their intuition. It's not like we have some kind of a innate ability. It's learned either through experience or through genes. Um, Regarding your second question, so you were asking about the end of humanity and AI, etc. So yeah, Stephen Hawking was talking about the singularity. He was saying eventually you're going to end up with an algorithm that can evolve so fast, train so fast, that it's just going to completely usurp humans. Um, I mean, hey, it could happen, but I don't think it's going to be happening any time soon. I think we're still very, very far away from generalized artificial intelligence. So just to provide some kind of background, AI has general AI and focused AI. Everything I've been doing here, everything I've shown here is focused AI. General AI is more like, a form of AI that can operate for a wide variety of situations. I don't think we've made any meaningful headway for general AI. And so, that idea of humans, of machines taking over the world isn't something that's going to happen until we reach true generalized AI.
Brilliant. Thank you so much. That scares me even more. I don't know, this intuition bit being learned. So we'll take the questions as they're posed. Question by Murtaza Hassan. Is there a concept of self-generating or self-evolving algorithm? If not, then how do we expect the machines to learn and evolve by themselves like a human, as is mostly hyped? That's his first question. If you can retain it, I'll just pose a second question as well. The second is, what dangers do you foresee in autonomous systems and what makes them autonomous? Will they be able to adapt to a variation in learned technique? For example, the helicopter flying, it goes into a loop and wind picks up or ground height changes. Will it adjust to that, or no? So these two questions, take them first. Thank you.
Right. So in terms of evolution, yes, absolutely. There are things in machine learning called GAs, genetic algorithms. And the idea behind a generic algorithm is in every epoch of your training, you introduce a random mutation into your algorithm. And, um, and the algorithm, if it survives, great. If the random mutation turns out to hurt the performance of the algorithm, it will be removed. So in a sense, it's trying to emulate natural selection. So yeah, absolutely. We do have instances in AI where you can evolve an algorithm. In terms of autonomous systems, so is the question about how can these autonomous systems
Adapt to a variation.
adapt,
Yeah.
right? Adapt to variation. Well, one of the things about learning is that you can either learn online or offline. If you're learning online, it's kind of like you're learning on the fly. So learning on the fly means while you're actually, you know, being implemented or deployed, you are optimizing yourself based upon the changing environment around you. And so, yeah, you could definitely have online learning occurring.
All right. So we have another question from Sohail Usman Ali. And he says that, is there any way I can control my data that is being used by third parties? Or is there any way I can recognize fake news on social media? And how do I know I've been targeted?
That's a great question. That's a really great question. In terms of controlling your data, um, there are all kinds of measures you can take. You can change the browser that you use. So for example, don't use Chrome. With Chrome, all your data is being fed to Google. You can use something like the Brave browser. So the Brave browser is a very privacy oriented browser. There are all kinds of other things you can also do to secure your data. You can use VPNs, etc. Um, and yeah, this is an ongoing conversation that's being had. And security, by the way, is something that's constantly changing. So as threats emerge, you need to be changing your own ways of handling those threats. So it's important to remain current with the latest threats out there.
All right, great. Sorry.
Okay. And so the other question was about,
How do
remind me?
how does one find out that they've been targeted and how to deal with fake news?
Ah,
How to
yes.
identify it, recognize it?
Yeah, I mean, again, it's a fairly you need to adopt fairly broad solutions because your threats can come from a broad variety of places. So you always need to kind of keep an eye out. Make sure your accounts are secure. Make sure your passwords are secure. Make sure you aren't being subject to any phishing. And yeah, again, you just need to uh, constantly keep an eye out for the latest changes and threats in the space. You can't actually know if your data has been compromised. So for example, when there were all sorts of leaks that happened, Yahoo Mail, for example, had a horrible leak a few years ago, where something like, I don't even know off the top of my head, but a large chunk of the world's accounts were basically compromised. And we didn't even find out about this leak until a while after it happened. The reason being that Yahoo claims that it itself did not realize this leak had happened, something like a year or more after the leak had happened. And so, this is a constant issue. If you're going to be relying on a trusted intermediary or trusted sort of a third party with your valuable information, then you're gonna eventually end up in situations like this. So the key is to not have to trust other intermediaries. The key is to be able to kind of take full ownership of your own valuable data.
Great. We'll have just last three questions for you. One is by Shari Kazi, what implications does Q learning have on reinforcement learning in terms of autonomous systems?
Right. So Q learning is actually a form of RL. And again, it can be used for all kinds of these applications. There are actually quite a few. It isn't just Q learning. You have like a handful of major uh, techniques which are being used, and I'm actually hoping to cover some of these in my machine learning course. So if he joins my course, he can find out more about Q learning and
That's
some
great.
of its intricacies.
You bet we'll be lining up for that course. So Syed Aliza Jafri asks that with AI added to the mix, especially in the realm of warfare, how can we ensure proportionality, accountability, and to a degree address the question of morality during conflicts?
Well, machines are by definition moral objects. They aren't immoral, they're amoral. They don't possess any morality at all. And so obviously the onus is on the humans who use these AI algorithms. And so any morality that society agrees a human is responsible for, that same morality should also apply for any usage that the human chooses to make of an AI. Again, thinking of AI just as a tool. It's an amoral object. It's the user who defines whether or not it's moral.
Excellent. And last question, I think you did mention to some extent AI in Pakistan, but Awais Mumtaz is asking, what is the future of AI in Pakistan? You did talk about lack of data, but are there any other aspects related to future of AI in Pakistan?
Right. So the nice thing about RL is that you don't actually need access to large data. And so in that sense, it's something that the country can begin to make use of. Um, uh, for the other two fields of RL, which is supervised and unsupervised learning, you have obviously you have a requirement for large data, and so in that case, it's hard to make any meaningful headway if our platforms aren't online and we're still, for example, manually having to uh, manual we have so much information if our healthcare, for example, was online, if the platform was an online platform, it would be so much easier to be generating that data and using it in a way that a machine can understand it rather than it sitting in a file somewhere. So that's obviously just one example, but yeah, online so that we can make use of these algorithms.
All right, Altan, there was an absolute last question, but I think I was logged out and logged back in, and I've lost that because it doesn't show up here. But it was, I think, about, autonomous weapons. Can they intrude a country's command and control system and disrupt it? I think it was to that effect.
Do you mean physically intrude?
Well, that's was the tricky part of the question because I think command and control system is protected by so many rails that unless and until access is given in the physical perimeter, I don't think there is any way a first strike would be different than an autonomous weapon hitting a command and control system. So I think there's some bit of lack of clarity in that question.
Right. So, related to this question, it actually brings up a very important point. For example, should or how can AI be used to enhance the command and control systems, for example, of the country, right? Can you use AI to somehow add in some kind of marginal utility in performance of the command and control system? Now, generally speaking, when you have these AI systems, you might have some kind of marginal utility, but you also have an increase in complexity. The reason being that, if you increase the complexity of a system or a protocol, you've effectively increased the threat surface. There are more ways now that things can go wrong, either unintentionally or else intentionally by some malicious actors who can exploit some kind of a loophole introduced by the increase in complexity. And so when we're thinking about using AI for, say, a command and control center, um, or for nuclear processes, there needs to be a very strong justification for using that AI because the increase in complexity can be quite costly. And
I
so it's a trade-off.
So I'd sent you a question similar to this in an email that I'd received from someone asking whether AI can be used to provide safety to nuclear plants or enhance the
Right.
safety structure. And you had probably said that it would be complex and difficult. You didn't think that, it should.
Yeah, I mean, again, the same principle applies. You use AI, sure, you might have some kind of marginal utility improvement, but
Yeah.
you've also now increased your complexity by a big amount. And that increase in complexity has these new threats which can now be exploited. And so you really want to be quite conservative when you increase the complexity for something as important as a nuclear power plant. For things like advertisements, who cares, right? Say you make a mistake, fine. You show somebody the wrong ad, no big deal. For things like nuclear processes, there needs to be a strong use case for AI.
Absolutely. Altan, with this, we come to the end. I'm extremely grateful to you for, breaking down such complex subjects to, very basic understanding for laypersons here. I really enjoyed it. I'm sure others also enjoyed it and learned from it, and it has increased their curiosity about the world we have already entered. Although Pakistan is slow to the race, but slowly getting there. So thank you so much for your time, and we look forward to once you open up your course on machine learning. Do advertise. Do let us know We'll share it with the students and faculty here and widely share it so that more and more people can learn. It's always good to have free resource. I'm so happy that you're not putting a tag on it. So thank you so much for being here with us.
Thank you, Rabia. It's been an absolute pleasure. And thank you all to the audience for attending.
Thank you so much. Thank you, everybody, for joining us and for great questions. It was a great, webinar. I really enjoyed it. I hope you did too. Have a good evening and a good morning to you again, Altan. And I hope you survive the presidential results that are about to come in. Good luck with that.
Thank you.
Thank you. Bye.